So in yesterday's class, I discussed with you about mainly how the electrons are moving with a constant speed or with a constant average speed. So finally what we have concluded, they are moving with a constant average speed. Why? Why this constant average speed? Because of collisions. Again, they are accelerated by battery, right? Due to electric force generated in the conductor, uniform electric field. So due to this reason, they are moving with a constant average speed that is calculated I square 0.07 millimeter per second. By using the formula I is equals to Q by N into A into I equal to I is equals to Q into N into A into Vd. From this, Vd is equal to I by Q into N into A. Right? A small q. The capital Q is net charge. That is converted into Q into N into A into Vd. Right? So here A is the cross-sectional area, N is the number of electrons count. Next, Q is the charge of electron, I is the amount of current. So that we discussed, right? So finally, what we concluded that Vd is equal to 0.07 millimeter per second is calculated, or we know the speed of the electron, right? So here electrons are moving through a conductor with a drift speed Vd equal to 0.07 millimeter per second, but how the bulb glows immediately when we switch on the bulb, right? Here it is taking nearly 100 seconds of time to move just it is 7 millimeters. Time needed nearly 100 seconds to move just a distance through the conductor or to cover the length in a conductor is equal to 7 millimeters, right? So how that reach the bulb from the source with maintaining this constant average speed. So is it possible to reach if it is maintained this speed? No, impossible. Immediately in fraction of seconds actually, not 1 second. So how it is possible? It is possible due to the electric field setup throughout the conductor immediately without any time gap, right? So it glows because of uniform electric field setup in a conductor irrespective to the length of the wire. That source what you are using, it may be the chemical field or maybe the electric field directly source, right? So that can set up the uniform electric field. So due to that, here simply that electric field generated by the source will make the electron to move in a specified direction. Actually random with ordered motion, right? So they are simultaneously starts if you switch off, right? So that's why the charge which is nearby the bulb will be accelerated due to the uniform electric field, and immediately it reaches the bulb and it makes the bulb to glow, right? So in which direction do the electron move? Can anybody? Is it in the direction of field or opposite to the direction of field created by the source? That we need to know, right? So here simply we can determine the direction of current, electric current, based on what? Sign convention of the charge and the drift velocity, right? Sign convention of the charge and the drift velocity. So here drift velocity is what? Simply it is the most speed of the charge, right? It is what? Speed of the charge, right? So here they are moving. Actually, which are free charges? Which are free charges? They are electrons here. So here, simply, they are depending on the sign of the charge Q and the drift velocity Vd. Because remaining in your formula, remaining what they are Q, sorry, N and one more is A. N and A. Number of electrons and the cross-sectional area. So that N and cross-sectional areas are fixed with their sign or the value, right? So that is here positive. N and Q are positive. Sorry, N and A are positive. Then here current direction depending on what? Only the charge and the drift velocity. So we can assign the symbol for the charges. If it is a positive charge, the charge of the proton or positive charge is taken to be positive, right? That is plus 1.602 into 10 to the power of minus 19 coulombs. If it is electron, that charge of the electron negative particle is taken to be minus 1.602 into 10 to the power of minus 19. Then Vd is positive for the both. So for electrons, Q is negative and Vd is positive. Then if you substitute that according to the sign convention, the product of Q and Vd remains as negative. So that negative signs, right? The negative sign what we obtained by the product Q and Vd, that will be substituted in the formula I is equals to N into Q into AVD. So in that, it will give you simply negative value for the current. So it is not mean that negative current, it is giving you the direction of current, right? With the free charges, electrons. So simply we can get it that negative symbol, electrons are moving opposite to the field direction. If you think about positive charges, right? If you think about positive charges, that positive charges Q value is positive and Vd value also positive. Then the product of these two will give you positive sign. Right? The product of these two quantities Q and Vd will give you positive again. So by substituting them in I equal to NQAVD formula, then you will get positive. So here the current, electric current can be taken as the direction of flow of positive charges. Direction of flow of positive charges. That means the current direction in the simple electric circuit from the positive terminal to the negative terminal. In anything, not only this battery, so in any circuit, the current direction is taken to be from positive terminal to the negative terminal. Then what about charges, electrons? They are moving opposite in the direction of electric field. Opposite in the direction of electric field. So electric field is set up first from positive terminal to the negative terminal. From positive terminal to the negative terminal, that electric field will be set up. So here electrons moving opposite in the direction of electric field called negative terminal to the positive terminal. Right? Electrons are moving from negative terminal of the battery to the positive terminal. This is about the direction of current and the direction of electrons moving to a conductor. Are you clear about this? Yes. Right. So now we'll move to the next one. Here that simply electrons are moving due to what? Electric field force. So force is there and the displacement is observed. Simply what happened? That electric field is doing something work or not in moving the charges. It may be the positive charge or maybe the negative charge. To make them to move, what is doing work? Force. So here simply, where do the electrons get the energy? It is because of electric field only, right? So electrons get the energy from the field, right? So something energy is acting, there must be work done. There must be work done. So here, what happened? It is simply when they are connected to the battery terminals without connecting, when the terminals of a conductor are free, right? When the terminals of a conductor are free, that means what? Not connected to the source. Then electrons are moving randomly, as you see here, right? So it is left free. Then in this case, what happening? The electrons are moving randomly. Once this is connected to the source, right? Once this is connected to the source, that means battery. Then what happened? Bulb is glowing. So from the bulb glowing activity, one situation one, what we concluded, electrons are forced to move towards the bulb only, toward the conductor, right? So from that we assigned ordered motion to the electron. It is just because of what? Presence of battery, working condition, right? That battery making the electron to move in a specified direction, right? So it is possible to change the direction of something by the application of force only. Do you agree with me? Do you agree with me? Put a quick reaction if you agree or disagree. Without application of force, you are unable to change the direction of anything. Do you agree or not? Use your quick reaction. Agree, disagree. Don't have idea? Right? So here look at one example I will tell you. Simple. If you are just rolling something on the floor, the moment because of force only, right? Always you are moving that something body on the floor in a straight direction. You don't want to change its direction. You will change the direction. How we can change? By pushing one of the hand forward, comparing with the other. So what happens? They can change the direction. Simple. Imagine the steering. To change the direction of vehicle, you are changing the steering direction with the application of force only. Is it possible without application of force to change the direction? The direction of anything changed by without application of force? Give me your quick reaction. Am I audible? Am I audible? Why you are very slower, lazy, right? Okay. So here simply you are changing the direction of something by the application of force. So here, which force is changing the direction of electron? Always that electric field accelerating the particles to move in a specified direction. So when you connect that electrons are forced to move in a specified direction. So without the application of force, it is impossible to expect. So here, from these, we can conclude that they are influenced by the force set up by the battery, right? So that force is doing something work. So from this, you are just understanding that terminals connected to the battery, electric field is set up, that field exerts the force on the electrons to move in a specified direction, that I am assuming the force as something Fe. What amount of force is existing on the negative particles or positive particles? That is amount of Fe. Fe amount of force is acting on them. Then here it is on the positive charges. If it is acting on the positive charges, the work is considered to be positive, and that motion of the charges are considered in the direction of electric field. If it is acting on the negative charges, it can be expected due to that negative symbol, right? The work is considered to be negative, idea that work is done against the force. So movement of electron opposite to the electric field. Movement of electron is opposite to the electric field. So here electric field is doing something work in moving the charges. So here simply, can you find the work done by the electric force? Right. So now the question is what? If it is doing something force, what amount of force it can do or it can work, right? So simply you are able to calculate that what work done by the electric force. How to find out that work done by the electric force? So here simple to find out that. Here we know work done by the electric force on free charges, right? On free charges, because remaining are fixed. Why we need to think about that positive charges? No need to think about that, right? They are just helping us in accelerating the electrons to attract always towards or to repel the electron using the nuclear force, right? So in that way only we can use that protons. Then free charges are what here? Negative charges, electrons, right? So that electrons are under the influence of this force. So here once the field is set up, right, the particle I am expecting something positive charge, right? Whatever it may be you are discussing with the positive charge, and we can assign that for the negative charge, right? So what I am expected here, positive charge is located one of the end of your terminal, right? So at A, the charge is located at the end of the wire at terminal A. Then the terminal B is there, ending. Starting and ending terminals are given as here A and B. So once you are connecting these to the battery, this A and B are connected to the battery, what happens? Automatically the charge influenced by the force, right? It can set up to move in a specified direction. Maybe it is from A to B or B to A, depending on the direction of connection with the battery, right? So here whatever it may be, I connected this. What I am expecting? So once this conductor is connected with the battery terminals, immediately, right, throughout the length of the wire, right, the length of the conductor is taken between A and B is L. So throughout this length of the wire, uniform electric field is set up, right? Uniform electric field set up. So I am expecting that uniform electric field set up from the terminal A to B in a conductor, right? Field set up in the direction of B. So from A to B, right? Then next here, always the movement of anything expected from higher amount to lower amount. It may be in terms of pressure, or maybe the pressure is indicating indirectly force upon the area. Force upon the area is nothing but pressure. So indirectly we are discussing about the force in motion, right? So higher force to lower force, right? High pressure to low pressure, right? So here high pressure is expected at A, right? If the particle is moving towards the right, towards B. So here that particle is expected here, positive particle, that means proton, right? Positive charge is expected. So field is applying something force Fe on the charge, right? So what happens when the force is applied on the charge? Automatically the charge started to move. So here, to bring the charge from left end to right end, or the terminal A to terminal B, I applied something force to move the charge. So I did something work, right? What I did something work here. Who is I here? That is electric field. So field does something work. Electric field does something work by applying the force on the charge, right? Once again, look at that. So here field is set up in a conductor. Once it is connected with the battery terminals, that uniform electric field is applying force on the particle to move in a specified direction that depends on the electrolyte of your battery. Then that force is exerting on the particle to move that in a specified direction. So automatically that expected here, just it is moving from A to B in the direction of field. So in the direction of field, what we expected, positive charges are moving. So it is positive charge. What about electrons? Opposite in the direction of electric field. So here that is expected from B to A here. If it is electron, it is expected from B to A, opposite in the direction of electric field. So simply what the work is done on the particle, that will be calculated by using the formula W equal to F into S, as you learned in your 9th class. So W is equal to F into S. W is the work done, F is the force, and S is the distance or displacement given by the particle with the application of force, right? So what the distance or what the changes you observed in its position called the displacement, right? So in the direction of force. So here I am using this W equal to F into S. But what about this F? F is Fe. F equal to Fe. And what about the displacement is given here? L, distance traveled. So S is replaced by L. S is replaced by L. So before that, here simply I need to know, right? I need to know simply here what is the work done on unit charge, right? So that purpose, what I am doing here, the same equation will be divided by the charge, amount of charge, right? So either sides I am dividing this equation. So what I will get, W by Q equal to Fe into L by Q. If you cancel, what give you here? Again, you are remaining with the same equation, right? Same equation, that is W is equal to Fe into L. Are you clear about this? Why I am divided? That I will tell you. Here I divided this to get the amount of work done on unit charge, because I applied my force on unit charge, maybe positive charge or maybe the negative charge, whatever it may be. I am not assigned the symbol. If I assign the symbol, I'll get minus. So it is indicating that moment of particle opposite in the direction of force, right? So here simply, have you got idea why I divided this? To get the work or to calculate the work done on the unit charge. The work done on the unit charge. So I got W by Q is equals to Fe into L by Q. So what the work done by you? What the work done by you on unit charge? On unit charge is now taken to be potential difference, denoted by the letter V. So V equal to W by Q. The W by Q will give you Fe into L by Q. So what we can write? V equal to Fe into L by Q. Right? V equal to Fe into L by Q. We can write the formula. Right? So that V equal to W by Q helping us to define what is V. Right? So V is what? Simply energy gap between the terminals. That is generated by the source. That is generated by the source. Sorry. Here V equal to W by Q. That V equal to W by Q will help you in defining the energy gap between the terminals of the battery. That is generated throughout the conductor, same uniform, right? So what is V here? Energy gap. That we can call it as potential difference. Potential difference. So potential difference we can define, right? Potential difference we can define as here the rate of work done on unit charge. For what purpose you are doing work? To move the charge or to bring the charge from end A to end B, one end to the other end. To move the charge from one end to the other end, you are doing something work. That amount of work done on the unit charge to bring from one end to the another end of the terminal is called as potential difference. So here W is measured in joules and Q is measured in coulombs. So units of these W by Q is joule per coulomb, but it is named as volt. So V takes the units volts. V is potential difference and the units of potential difference are volts here. So potential difference is defined as work done by the electric force on unit positive charge to move it through a distance L. Move it through a distance L. So that we can here calculate by using the formula V equal to W by Q. How many of you got clear idea about potential difference now? Go to quick reaction. How many of you got an idea about potential difference? 1, 2, 3, 4. Right. So remaining 2, 3 members are in confusion maybe. What about Kaushik? What about you? Kaushik, Rohit, Tejaswini? Are you in confusion still? No confusion? Okay. Rohit and Tejaswini. No confusion. Rohit, do you have anything to clarify here? Do you need anything to clarify? Nothing? Okay, no response from you. Let's go to another here. Right? So here we got an idea about potential difference. We got an idea about a potential difference. What the potential difference actually doing here? It is doing something work for you. What work? It is helping you to move the charge from one end to the another end of the conductor. The charge moving through a conductor from one end to the another end due to what? Potential difference. Right? Potential difference. That you need to keep it in your mind. Right? So here I am closing this meeting. Join immediately in the next meeting.